let's study about containers. So, this is one of the fundamental concept required to understand the Docker and Kubernetes and containerization, right. So, what basically is a container? Okay. Imagine you are developing a web app that has three main components: a React front end, a Python API and a database, PostgreSQL database, right. So, basically you are building a web application and it has these three components: Python in the back end and database PostgreSQL and a React front end. If you wanted to work on this project, you would have to install these three. We know that. If in my machine, in my laptop, if I want to build such kind of application, I have to install all these three, right. Then how do you make sure that you have the same versions as the other developers on your team? Do we check this? No. Somebody has joined the team in 2025, they might have installed 3.1.3. You joined in 2026, you are having a latest version, you might have installed this version of that particular software, right. So, there are the version of the software which is installed in both of you and your colleagues machine could be different, right. So, this is the aspect. Or your CI/CD system, you are using some CI/CD pipeline, okay. So, what is the version installed in that pipeline, or what is used in the production? Since we are talking about different environments, right, SIT environment, dev environment, prod environment, UAT environment, like this we have different environments. Which version is installed in the developer environment or which is installed in the production, we do not know. And if there is a difference in the versions, that program will not execute there. The code which is executing in this environment may not be executing in UAT or SIT or production. It will fail because there is a lot of dependency with the version, especially when talking about Python programming, right. The second thing, how do you ensure that the version of Python or the database your app needs is not affected by what's already on your machine? It means in my laptop, in my machine, I already have some version of Python, some version of Node and some version of PostgreSQL. Do I know, how do I know that for that particular requirement, for that building web application, the current versions in my machine, are they enough for building this web app? Maybe the requirements given for this web app are different, which requires some latest versions than what is installed in my machine. So, how do you manage these potential conflicts, right? So, maybe the environment, I am working on dev environment, there is SIT environment, there is UAT environment, the version of the software in my machine is different from what is there in other environments, right. So, to handle all these version issues, right, all these dependencies on the configurations and settings, okay, to avoid these problems, we enter into containers. This is the motivation for introducing the concept of container, okay, because my machine could have, see, I am installing some particular version X, Y, Z version in my machine, right, and then I am running the code, executing it, I am then pushing into GitHub. Somebody else is doing pull operation, he is taking the code which I have done the commit, he is trying to execute that, right. The version there might be X, Y and Y, which both are not compatible. So, there is a problem of the dependencies, the version of the software in different machines. That is what we are saying, same version as the other developers have or our CI/CD system has. So, for that reason we use the concept called container. So, what is a container, right? So, container here are containers are isolated processes for each of your app's components. what are my components in my web app? For example, I have taken an example here that I am going to build a web app. It has three components: a front end, a back end, and a database, right? So, they are isolated processes for each of your component. For front end, one container C1, for back end another one, for database another one, right? Each component, the front end React app, the Python API engine, and the database runs in its own isolated environment. We are not running those three in a single environment. They are running in their own independent environment, completely isolated from everything else on your machine. Okay, so they are not running in my machine, right? They are running something above virtual machine. So, okay, something which kind of a virtual machine, but virtual machine and containers both are different, right? But basically, virtual machine is it's a software, or it's a environment where I can install any operating system and I can run any software there. So, container is a fine tuned version of virtual machine. So, I will create a box. This can execute independently in an isolated environment without depending or without any impact with the other containers, right? So, container is an isolated process. It is a box. For everything there is a separate container. For front end there is another container. For back end Python API there is one container, and for database there is another container. Completely isolated from everything else on your machine, right? So, why is container so famous? What are the, or I would say, what are the benefits of or what are the features of containers, right? So, containers are self-contained, means each container has everything it needs to function without or with no reliance on any pre-installed dependencies on the host machine. In my laptop, in my machine, to run a Java program, I have to install Java, I have to install Java runtime environment, I have to do class path settings. Then only I can run the code. Okay, this and all I have to do in my local machine, then only I can execute. But container is not like that. You will need, with no reliance, with no dependency on any pre-installed dependencies on the host machine. Okay, everything will be in that box only. All that settings will be doing in this container only. It will contain everything. We need not do anything inside it. We need not do anything in my local machine. Everything is available in that container box. Second one is isolated. Since containers run in isolation, they have minimal influence on the host and other containers. A container can execute in any operating system, in any kind of host. It has very less impact or dependency with the host, increasing the security of our applications, right? Then the third feature is independent. They are independently managed. Each container is independently managed. Deleting one container will not affect the other containers. And finally, they are portable. They can run anywhere. Okay, whether once you write some code, push it into container, that container can execute in your machine, in your friend's machine, in another operating system machine, or in the cloud. It can execute anywhere. So powerful and so generic is this container concept, right? What is the difference? I was talking about this container versus virtual machine. What is the difference between the container and the virtual machine, right? So we will study this in cloud computing, but let's see a simple or let's just see a slight difference between virtual machine and container. A virtual machine is an entire operating system with its own kernel, hardware drivers, programs and applications. Okay, whereas container is simply an isolated process with all of the files it needs to run, right. It means, see, your physical hardware is here, this is your physical infrastructure hardware. Hardware, when I say, when I am talking about compute facility, I am talking about your RAM, I am talking about storage, I am talking about your networking things, and I have installed an operating system, let us say Windows. But to demonstrate Linux to you, I have installed a VirtualBox, right. VirtualBox, or I have installed a VirtualBox which can help me, or which is indirectly creating a virtual machine. In that virtual machine, I have installed the Linux operating system, and then I have showed you the demo of Linux commands and shell scripting. I did not change my underlying operating system. Instead, on this machine, I created a VirtualBox, or I created a virtual machine in which I have installed Linux operating system, and then I have done, it means in a single machine I am able to run two different operating systems. That is possible with virtual machine. Whereas in container it is not, it is also same, it is also something like virtual machine, but OS is not there here. It is independent of the operating system, independent of the operating system, right. It is it has all the dependencies. See, container is simply an isolated process with all of the files it needs to run. All that we are clubbing together and putting in a box. This is the difference between the virtual machine and the container, right. So, this is the root for the concept of containerization, right. We are going to talk more about this once we, so only container cannot be understood with a simple example, okay, because we need to understand the linked concepts, something like container, then I have to talk about image, then I have talked something about registry, okay, and all three are linked with the concept called Docker, right. So, we will understand them now. For now, we will try to understand what is container, what is image, what is registry, then we will try to club them and understand all these three and how they are linked with the Docker.